Timers. When designing an automatic system, there may be a need to delay an output or to delay the system and give the priority to execute another output or another system. A timer is a very useful tool for designing and creating automatic systems. Example of where we can find timers. The Delta motor starters. We use them to construct panels, electrical control panels, especially, well, for example, Delta motor starter. You can use them in automatic gates, automatic access, barriers. When they lift, they have to spend some time before they come down, or when the automatic door gates open, they spend some time before they close. Those things are duties performed by timers. We have them in our home gadgets as well. So the most popular types of timers in the industry are the turn timers and the tough timers. The turn timers are the on-delay timers. They have to, as soon as voltage is applied, they spend some time before after the time that has been set has exhausted, it will switch the commutator and it will switch the load. And it will remain engaged until voltage is removed from the timer. This is for the on-delay timer. For the tough timers, which are these ones are when voltage is removed, is when they switch. They actually put on the load. This is very useful this is mostly used with auxiliary contactor timers. So there are also timers in PLCs in variable frequency drives. And we have standalone timers like the timers we see in this slide. Timer is a very broad topic, and we are going to look at it from a practical point of view. We're not going to look at it from an academic point of view. We're going to look at it in a basic application in automation and controls, in constructing panels, electrical control panels. We can be complex. Timer is a very can be very complex because it's a very vast topic. So we're going to focus on delay timer. Turn timers are used to delay the turning on output, turning output on and output on. Turn timers are known as the on-delay timers, or TD for delay timer. That's an example of an on-delay timer, Schneider Lattice 2. This is a typical block for an electronic timer. When voltage is applied to the power supply circuit, when voltage is applied, the timer will start to count, and then when the time is exhausted, it will trigger an output. The output is to switch the load, to switch the contact. The normally open contact will become normally closed. Normally closed contact will become normally open. Below here we have the light emitting diodes, which are indicating the state of the timer, and the timer is active. These are light emitting diodes that we see here. So if it's an electronic timer, so the voltage is applied to the coil of the timer. The turn timer starts counting. When the time is exhausted, normally closed contact will become normally open. Normally open contact will become on timer, normally closed. To maintain this state until voltage is removed from the coil. Auxiliary contact timer depend on the contactor to be energized and pulling. So as soon as the contactor pulls in, before the timer can begin to count a set time, and when the time has exhausted, the contact will switch the load. These are home run timers. They are electronic timers as well, they use current, but to set it, it's analog timer. Or it's an electrical timer, but it's also an analog timer because you have to wind the knob to set it. So now this is a multifunctional electronic timer. It can be configured as a tough timer, or as a turn timer, or the other functions that can be performed with it as well.
You know that how a timer works is that when it receives voltage, if it receives voltage through the A1, when it receives voltage through the A1, then it will activate the timing. And then when the time that you set has reached, then it will move the switch. This is the switch that it moves. So this is how to use it in a project. The project that is going to control, let's say for example, it is going to activate this relay, this relay, when the time that you set has been reached. So what you do is that you supply this coil with negative, but you make the phase, you apply with neutral. All that the timer can do is to switch the contact. So it switches between 16 and 18, and then it's common. The common is 15 is common. So 16 is normally closed, 18 is normally open. So you can see it's drawn here. So you can see the small diagram here, which explains it, how it works. And it also shows you what the voltage, the input voltage. It says that the input voltage for the coil can go from 12 volts to 240 volts. You can also put AC, DC voltage into to activate the coil of this timer. Use it to do time of timing, delay on or delay off. So depending on what function you choose, it does the timing here. So these are all the options you can use to do the timing. Well, I just want a simple timing, which is just delay on. So if I just put it on E, that's the simple timing. And then this is if I put it on E, that's the simple timing. And then the time, it goes from 1 second, 10 seconds, 1 minute, 10 minutes. But if you want to get say you want to get 2 minutes or 3 minutes, then you have to adjust both. Adjust this one to 1 minute and then adjust this one till you get the timing that you need. So what it's going to do is that it's going to be supplying positive. It's going to supplying phase to the contact. It's going to be supplying phase to the coil. So you can put AC or DC here, depending on what you want to use it for. So when it switches, it will close, and this will activate. So how I've used it, so when I supply voltage, I'll supply voltage to the timer. The timer will begin to count the time, and I put it for like 30 seconds. So after 30 seconds, it's going to switch this one on. So now we'll try the timer. I'll just switch it on. I'll switch on the timer by activating this. So now the timer is on. Timing, it has not, see the light blinking. When it's full, it will activate the coil, the relay. So I have it for about 30 seconds or so. So now it has activated this coil, and it will remain like this until you remove voltage from the coil. Until you remove voltage from the timer. So you can use it to switch motors. You can also use it you can use it to switch motors and switch and that's what I intend to use it to do. I intend to use it to delay the activation of a variable frequency drive, and then when it goes off, everything goes off. When it starts to time, when it's activated again, it starts to calculate time. When the time is right, it will activate the relay again. All right, thanks for listening, and see you on the next one.